If you're new to my channel, welcome. Before watching this video, I highly recommend you watch my low pass filter video linked in the description below. Let's crack on with some intuitive observations. Here is today's circuit. It looks very much like the low pass filter, except I've swapped the capacitor and the resistor. The input is on the yellow trace and the output is on the blue trace, just like my previous low pass filter video. Let's start our observations. I have 1 Hz input and no output, so we can already create an equivalent approximate circuit. The capacitor is acting like an open circuit, leaving the resistor grounding the output at this low frequency. As I travel upwards in frequency, stepping 100 Hz at a time, we can see the output amplitude slowly grow. This is our second equivalent circuit, where the capacitor is starting to act like a resistor. This resistance we actually call reactance. Finally, we're in the megahertz, and we can see the output nearly matches the input. Our capacitor has become more like a short connecting our output to our input. Let's just recap all our equivalent circuits. When we have a low frequency input, the capacitor acts like an open circuit, meaning our output is connected to ground. When we head into the kilohertz, the capacitor starts acting like a resistor, and the output amplitude starts to increase as we approach our break frequency. Once we have passed the break frequency, then our capacitor acts like a short circuit and the input can be seen at the output. Here we have our amplitude versus frequency plot again, and the break frequency is at -3 dB, just like last time. However, this time the curve is mirrored to that of the low pass filter. That means it allows all the frequencies above the break frequency to pass and will block those below it. This operation is the complete opposite to the low pass filter. We can see from our calculations that our break frequency is 1591 Hz. Please remember that we have not considered phase shift, and our approximate equivalent circuits are only used to help build understanding and not for further analysis. Finally, have a look at this transistor circuit. Hopefully, you should be able to recognize that it has 2 high-pass filters, one on the input and one on the output. Without needing to fully understand this circuit, you should realize that it is blocking low frequencies but letting through high frequencies. Simple. If you have seen my potential divider video, which I'll link in below, you may also recognize that just after the input capacitor, there is a potential divider which is DC biasing the base of the transistor. If you don't know what a transistor is, don't worry, I will certainly cover these in future videos. However, just be impressed that after watching just 2 videos, this one and my potential divider video, you can almost fully analyze this circuit. Who said electronics was hard? I hope this video has been useful. Please give it a thumbs up and comment below. You must try out this circuit, remember, to convince yourself that it really works. If you can't find a good reason to make your own lab, you can try it out in a circuit simulator such as LTSpice, which I've also done a video tutorial on. Again, you guessed it, it's linked below. Until next time, keep experimenting.